Okay, so we're going to answer here AQA Core 1 May 2006, question 1. Okay, in this question, they're telling us the point A has coordinates 1, 7, and the point B has coordinates 5, 1. And I've done a little bit of a sketch of that here. It says find the gradient of the line AB. So, as you can see, the gap is 6. I put minus 6 here because this is a negative gradient, and that's the gap in the y. The gap in the x is from 1 to 5, it's a gap of 4, which gives you a gradient of minus 6 divided by 4, which is minus 3 over 2, which is minus 1.5. Okay, using this form of my formula for equation of a straight line, y minus y1 equals mx minus x1, I can choose either 0.17 for A or 5,1 for B. Either will work. I'm going to use 0.17, which is obviously on the line AB. Put that in here when y1 is 7 from A, x1 is minus 1 from A, and the gradient is minus 1.5. This gives me y minus 7 equals minus 1.5x plus 1.5. Minus 1.5 times minus 1 being plus 1.5. Y plus 1.5x equals 8.5. If I take the 7 across and bring the minus 1.5 across, and then I'm going to tell the examiner that I'm going to multiply by 2, and this gives me 2y plus 3x equals 17, which is what they wanted us to find in part 2 of question 1. Okay, this is where the examiner in part B starts to get a little bit feisty. He says the line AB intersects the line with equation x minus 4y equals 8 at the point C. Find the coordinates of C. Okay, so in order to tackle this, I'm going to set myself up with a simultaneous equation. This is the equation of AB, and this is the equation of the line they've just given us, x minus 4y equals 8. Okay, I need to get either my y's or my x's level in order to solve a simultaneous equation and find the coordinate of the point where those two lines meet. So what I'm going to do is equation 1, I'm going to multiply by 2. That gives me 6x, 2 times 3x is 6x, 2 times 2y is 4y, 2 times 17 is 34. And I'm going to call that equation 3. I'm now going to do equation 3, add equation 2, x minus 4y equals 8. I'm adding because I've got plus here and minus here, that will cancel the y's. 6x plus x is 7x, 4y plus minus 4y is gone, 34 plus 8 is 42. Divide both sides by 7, leaves you with x equals 6. Nice one. Okay, then we'll take it a little bit further. What I'm going to do is take this value of x, put it into equation 2. I'm telling the examiner what I'm doing. I could use equation 1, either will work. This gives me 6 minus 4y equals 8. Bring the 8 across and the 4y across to the right to make it positive. That gives me minus 2 equals 4y. Divide both sides by 4 and I get minus a half equals y. And this gives me the point where the two lines cross, 6 minus a half, and they're calling that C. Okay, they then want us to find, in part C, they want to find us the equation for the line perpendicular to AB at A. Okay, so I've got my handy little equation here. The gradient of one line times the gradient of another line equals minus 1 if they're perpendicular. The way I remember that is two mothers fighting and one of them loses a tooth. Bit of craziness there to help you memorise that formula. So the gradient of AB times the gradient of the line they want us to find must equal -1. Therefore, the gradient of the new line we're trying to find equals -1 over the gradient of AB. When we put the figures in, we get the new gradient is -1 divided by -1.5, which is the same as 1 divided by 3/2. Okay, because of the two negatives we can consider as positive. When you divide by a fraction, you flip the second fraction, flip it for real, and then multiply. And that gives me 1 times 2/3 is obviously 2/3. So my gradient for this new line is 2/3. Now again, using the coordinates of A, 1, 7 from before, and our handy little equation of the line formula, y minus y1 equals mx minus x1. Putting in my values for A gives me y minus 7 equals 2/3 x minus 1. This would give me full marks here if I stopped here, but I'm feeling a bit flashed today, a bit fly. I'm going to show the examiner what I can do. So I'm going to expand the brackets. Y minus 7 equals 2/3 x minus 2/3. If I multiply everything by 3, this gives me 3y minus 21 equals, multiplied by 3 here and here, cancels with the 3's on the bottom, 2x minus 2, and bring the x across to the left hand side to give it in the form as we had in part A, and that gives me 3y minus 2x equals 19. And that's us being a bit flashy and showing the examiner we really know our onions. Nice one.